We're going to begin Chapter 5, Section 1, where we begin our lesson on trigonometry. This Chapter 5 is a different Chapter 5 from our normal textbook, right? So we actually just did Chapter 5 with exponents, but we're going to use a different textbook just because I think our textbook combines degrees and radians in each section, but we want to do everything in degrees first and then move on to doing everything in radians. Okay, so this first lesson is just going to talk about angles. You guys have seen angles a bunch already, all right? But let's get into like the actual terminology of what makes up an angle, right? So let's just say we have a ray, right? Hopefully you remember what a ray is from geometry, right? It has an endpoint and it goes forever and ever in one direction, right? So this goes forever and ever like that. If I were to take another ray at that same point, at this same exact endpoint, and I were to rotate it, all right, to a certain amount, that would get us what we call this little bit on the inside, which is an angle, all right? And typically we denote angles with this little Greek letter theta. Let me erase it, right? It should look like a little O with a slash through it, right? So typically we use theta to denote an angle, which you guys, again, have seen a bunch before. But the reason I drew this first is just to label each part of this. The ray that you start at initially, right, is called the initial side. All right? And then the ray that you end at is called the terminal side. All right? So nothing super crazy there, right? That kind of shows up in these little images that I'm showing you. The difference between what I drew and what's in the images is that we can relate angles in a coordinate plane, right? What I just showed you is just any angle in space, right? But the angles that are pictured in these little graphs are specifically in a coordinate plane. Now, if you draw an angle on a coordinate plane and you make the initial side the positive side of the x-axis, right, with an endpoint at the origin. So this is your endpoint, it's at the origin, and this is your ray that you're starting it, that's your initial side. Any angle that you form with that property, that it starts on the positive side of the x-axis, is an angle in standard position. All right? And let me just write out what I just said, right? So in standard position, right, the initial side is on the positive side of the x-axis, right? And it's still going to have a terminal side, right? This one pictured here has a terminal side still over here, right? So I have this little angle theta right here, right, represented by this little space, all right? And this is what we call a positive angle of rotation, right? Notice a positive angle of rotation goes counterclockwise, and if I move over here, we have kind of a similar image, right? I have another angle in standard position with the initial side on the x-axis, but this time the arrow is pointing this way, all right? So it's actually going clockwise, right? Clockwise is a negative angle of rotation, all right? We typically, in this particular lesson, we're going to refer to the measurement of the angle in degrees, all right? Notice if I were to take an angle and I were to have a ray go up until this part of the y-axis, right? So if I'm drawing an angle so that the terminal side is on the y-axis, the positive side of it, that's going to get us what we know as 90 degrees, right? And if I go around all the way to the negative side, so if my terminal side is on the negative side of the x-axis, that's going to get you 180 degrees, right? If I go another 90 degrees and I end up on the negative side of the y-axis, right, this is 270 degrees. And then if I go a full rotation, that's going to get us at 360 degrees. All right, notice if I go around the full amount, that ends up at the exact same spot as if I didn't rotate at all. So 360 is actually the same as 0 degrees. All right, and that's the exact same thing with the negative angles, right? Something like negative 90 would be down here, right? Because you're going this far, right? You're starting and you're going in the opposite direction of what we did before, right? So you're going in the negative direction, right? And then negative 180 would end up over here, negative 270 would end up over here, and then negative 360 would end up here. But we also have a 0 degrees right there, right? So all of these are the same, all right? What we're going to do in this lesson and in the lessons to come is much of the angles that we draw are going to relate to a coordinate plane, right? So it's important to know what angle measurements represent what part of your coordinate plane, right? So for example, you guys know that a coordinate plane can be split up in quadrants, right? So our first quadrant is right here. And notice that the first quadrant is between 0 degrees and 90 degrees. So for example, if I have an angle like this, I'm going to say that that's about, 60 degrees, all right? That is between 0 and 90 degrees. Notice in the second quadrant, that's between 90 degrees and 180 degrees. So if I have an angle like this, for example, where that is my terminal side, then I'm going to say that that's approximately, I'm just going to guess and say 150 degrees, right? And that's between 90 and 180. And then notice in the third quadrant, right, that's 180 and 270. So any angle, right, let's just say, for example, 200 degrees is going to end up in the third quadrant. And then between 270 and 360 is in the fourth quadrant. All right, so for example, like, 310 degrees, right, would be in the fourth quadrant. But that's kind of just an introduction of how these angles relate to the coordinate plane, right? We're not really going to use much of that information now, but you're going to see in the next lesson, I'm going to use words like standard position, and I'm going to refer to the quadrants and such, right? So that is good information to have. All right. What we're actually going to start with is examples involving coterminal angles, right? And that prefix co, right, when you have that word, that prefix, right, that means that this involves things that are being shared, all right? So I'm sharing terminal sides, all right? Two angles that share a terminal side, all right? So these particular angles have the same initial and terminal side, but they have more or less rotations, all right? I'll show you what this means in a little picture. Let's just say I have an angle like this, right? In standard position, again, it's going to be the initial side is right here, my terminal side is right here, and that is my angle, all right? But if I go all the way around, like let's say I loop all the way around a full rotation, and then I end up still at the same spot, right? That ends up kind of looking the same, right? It kind of looks like it's in the same spot, which it is, right? It is in the same spot. It's just you have an extra rotation, all right? Similarly, I can go backwards and I can also end up in the same spot, right? They share that terminal side, all right? And then what we do to find a coterminal angle is we add or subtract 360 degrees, all right? Because 360 degrees is a full rotation. All right, so I'll show you what that's going to look like in the next page. All right, so we want to find two coterminal angles, positive and a negative, all right? So I'll start with this first one, right? I have 908 degrees. I can either add or subtract. I'm going to show you that if you subtract 360, you get another angle, right? So 908 minus 360 should get you 548 degrees. And then that's one of our positive coterminal angles. Now I want to find a negative, all right? So if I subtract 360, that's going to get us 188, right, which is still a positive. So you can use either 548 or 188 as your positive. It doesn't really matter. But you can subtract 360 again, right? And all of these angles that I'm writing down end up at the same spot, right? So when I subtract 360, you end up with, I'll write it over here, negative 172 degrees, all right? And that's our negative coterminal angle, all right? So if you were to draw these, then they would end up again at the same spot. I'll use 188 and 172, or negative 172 as an example. Again, remember 180 is a full rotation, so 188 would be a little bit past it, right? So then our angle would look something like that. Now negative 172, if I go negative 90 degrees and then negative almost to 180, but not quite, you're going to end up at that same spot, all right? So then you have that both angles are touching that same terminal side, all right? And that's just the idea of a coterminal angle, but you guys can see actually finding it, it's not so hard. You're just adding and subtracting, all right? Now, when we do negative 75, let's add 360 to find a positive coterminal angle, right? So if I do 75, or negative 75 plus 360, that's 285, that's a positive. To find a negative, I'm gonna subtract 360 degrees. All right, so 75 or negative 75 minus 360 is going to get you negative 435 degrees. All right, and now let's do the same thing with the next one. I have negative 203. Again, to find a positive, I can add 360 degrees. All right, so doing that is going to get us 157 degrees. All right, and then to find a negative coterminal angle, I'm just going to subtract 360 degrees. All right, and that's going to get us negative 567. All right. Oh, just kidding, actually. I did 207 and 2 instead of 203, right? That should get you negative 563. Whoa, I'm not drawing that right. Negative 563. Okay, that's better. All right, so now 699, we can do the exact same thing. It's already a big positive number, so let's subtract it and let's see what that gets us, right? If I do 699 minus 360, all right, it should get us 339 degrees, so that's a positive. And I need a negative, so I'm going to subtract it from this exact number. All right, and then when I do this, that should get us a negative 21 degrees. All right, so that's it for finding coterminal. It's just adding, subtracting. Should be super easy. All right, the next idea that we'll talk about in this lesson, the last idea is going to be the degree minute second notation. All right, the degree minute second notation is just another way to write your angles. If you convert from one to another, you'll get equivalent angle measurements, just written in a different way. Degree minute second notation is typically used in like navigation, or like if you check a map, right? It usually has like latitude, longitude, that sort of thing. It's just slightly a more precise way to get an angle measurement, right? But I'll show you how to go from one to another. All right. So convert from decimal degree to degree minute second, or vice versa. All right, so the notation for degree minute second, right, I'll tell you that numbers 5 and 6 are in degree minute second notation, and you can tell because there are no decimals, right? If it's a decimal degree, of course, it's going to have a decimal, right? So look at number 5, for example. All right, so I have 74 degrees, all right? This is going to represent, again, the degree part of it. If you see one singular tick mark over a number, right, that's going to represent the minute. And then if you see the 2 tick marks, that's going to represent the second. So this is degree minute second notation, and you want to convert this to decimal degree. All right, and I'll show you. To do it, it's actually pretty simple. All right, so I'm going to take the whole number. That's still going to be your That's still going to be the whole number of your decimal degree. And then I'm going to add the minute over 60, right? Think of the minutes in an hour, right? 60 minutes in an hour, plus the seconds over 3,600, all right? Think of the seconds in an hour, all right? That's how we get those numbers. And then all you would do is you would punch this into a calculator and you would get your answer that way. All right, so let me do this now. And it should get you to 4 decimal places, should be 74.1372 degrees. All right, and that's our answer as a decimal. All right, so shouldn't be too bad. I'll try another one. Again, this is in degree, minute, second notation. I have the degree of 165, the minute of 51, and then the seconds of 9. So again, what we're going to do is I'm going to do the whole number, the degree, plus the minutes over 60, plus the seconds over 3,600. And then again, punch this in a calculator, see what you get. 9 over, okay, this should get you 165.8525 degrees. And then that's your answer in degree, minute, second notation. All right. So it shouldn't be too bad. I'll show you how to do it if you're already given a decimal degree. There is a way to convert this to degree, minute, second, right? So this is a decimal degree, and I want to convert it to degrees, minute, seconds. All right. So the whole number of your decimal is still going to be your degrees. So I have 34 degrees. All right, that's the degrees. The minutes is going to be the decimal times 60. All right, so I'm going to do 0.817 times 60. Again, punch that in a calculator. And then we get 49.02. The whole number of that is going to be the minutes, so 49 minutes. And then we repeat the process with this decimal, right? 0.02, I'm going to do 0.02 times 60, and then I'm going to get an answer from that. All right, and this is going to get you 1.2, and I'm just going to use that number as the second. I'm not going to keep the 0.2 with it. All right, so that's my answer in degree, minute, second notation. All right, and then I can do the exact same thing with the next one. All right, this is my degree, the whole number, 59 degrees. The minutes is going to be the 0.08754 times 60. So again, punch that in a calculator, and then we get 5.2524, right? So again, I'm going to use that number as the minutes, and then I'm going to use this part of it as the decimal, so 2524 times 60 again. And that should get you 15.144. Again, you're just going to use the whole number part of it, and then that's your final answer. All right, kind of a strange topic, nothing too exciting there, but that's it for this lesson. This particular page is kind of like its standalone skill, right? We don't really use it outside of this particular lesson, but we for sure use coterminal angles, right? You're going to see in later sections how that's useful. But yeah, that's it for this lesson.